Okay, Unit 11, transformations. Transformations are figures in a plane that can be reflected, rotated, translated, or dilated to produce new figures. The new figure is called the image, and the original figure is called the pre-image. The operation that maps or moves the pre-image onto the image is called a transformation, and the symbol looks like this for maps onto. One of the special transformations is an isometry, and basically an isometry preserves the length. It keeps the length and the shape. It's just basically moving it. So all things are congruent, but we are moving it in a different direction. But it keeps the same length, or you can rotate it as well. Now for this example, we want to know, what does triangle ABC map onto? Well, if you compare triangle ABC to triangle HSR, well, we want to make sure the angles are corresponding as well as the sides. So I want to make sure that triangle ABC, well, angle A is 30, so A corresponds to R. And B, well, we didn't find B, but if we do 30 plus 40 and subtract from 180, we know that angle B is 110. So B is 110, and the same thing for H. H is also 110. So B corresponds to H, and C corresponds to S. C is 40, and S is 40. So ABC corresponds to RHS. Well, I want to do the same thing for the other one, but I'm going backwards. So SHR is coming from what triangle? So, or the, I mean, basically, we know what triangle it comes from, but we have to make sure that the order is correct. We already did that. We know from the first one we did that A has to correspond to R. Well, since R is last, we know A has to be last as well. S corresponds to C, so C has to be first, and B is corresponding to H, so B has to be in the middle. So how we read this is C triangle CBA maps onto triangle SHR. Now, point symmetry, when a figure or graph is rotated about a point by exactly 180 degrees, and it is the identical, when you rotate it, it is identical. So for example, if I took this shape, took any of these and rotated 180 degrees, they are going to be the same picture. So think about this one being rotated 180 degrees. Well, it's still going to give me the same thing. This one, if I rotate it or look at it upside down, is another way to think about it. It's going to give me the same shape, and everything stays the same. For line symmetry, it is a line that divides into two congruent parts. So for the first shape, how many lines of symmetry do we have? So we have 1, 2, 3, and 4. If I put a 5 here, it doesn't have 5 lines of symmetry. 5 and 1 are the same line, so you only have 4 lines of symmetry. For the last one, there are no lines of symmetry. Now, these are a couple of SOL questions that we want to go over. A regular quadrilateral has what type of symmetry? So if you think, first of all, we need to know, what is a quadrilateral? We're talking about a four-sided figure. Regular means that all sides are equal and all angles are equal. So basically, we're talking about a square. All sides are equal, all the angles are equal, 90 degrees exactly. So line symmetry, yes, we have line symmetry. And So we definitely have line symmetry. And for point symmetry, if I turn it upside down, I'm going to have point symmetry as well. So you have both point and line symmetry. Now for example 2, star find, it says is symmetric with respect to the x-axis. The coordinates of point A are 8, 6. What are the coordinates of N? So basically I'm going to draw over the x-axis, and the top is symmetric with respect to the x-axis with the bottom. So basically A corresponds to N, T corresponds to D, R corresponds to I if I reflect it over the x-axis. So they give us A is 8, 6. And since I'm reflecting over the x-axis, the x actually doesn't change. So I'm still going over to 8. But however, instead of going up 6, I'm going down 6. So the answer for this one should be A.